Today we are going to talk about projectile motion and how to solve mathematically problems that are launched horizontally. When we say launched horizontally, we mean that all of the starting velocity is taking place in the x direction and that none of the velocity is making the object move up and down. And so if a ball rolls off a table, that would be an example of something launched horizontally. Or let's say you shoot a bow and arrow horizontally or a pellet gun horizontally. The idea is that you are pointing it just left and right, not up at an angle or down at an angle. And so when something is launched horizontally, and whenever we solve projectile problems, we're always going to start off by making a chart, because when something is in projectile motion, it is moving horizontally in the x direction, left and right. And it's also moving vertically in the y direction, up and down. From the lab, you know that the acceleration of a projectile in the x direction is going to be 0. There are no forces making it change its velocity forwards or backwards. You also know that in the y direction, the acceleration is always the acceleration due to gravity, and you can use that as either negative 9.8 for mastering physics, or negative 10 meters per second squared in our sample problems or in our homework worksheets. So this is like an always statement. Every time you do a projectile motion problem, you can just list the horizontal and vertical acceleration as if they were given to you in the problem. Now, in order to solve mathematically for some variables, we need to be given other factors. A lot of times they'll tell you how fast the ball is rolling while it's on the table. And so that they'll say something like, this ball is rolling at 3 meters per second off the edge of the table. And again, that starting velocity is all taking place in the x direction. And what that really means, and this is a key factor, when something is launched horizontally, there's a hidden variable. That hidden variable is that the starting velocity in the y direction is going to be 0 meters per second. And so this is something that you have to know because it's launched horizontally, that the problem won't say out loud specifically. That when something is launched horizontally, the starting velocity is all in the x direction, and none of it is in the y. All right, and so just by telling you how fast it's rolling, and also by telling you the height of the table that this falls from, maybe it's a 2-meter tall table, that's all the information you would need in order to solve for the time that it takes to hit the ground and to solve for the range. When we say the range, we mean our horizontal displacement, that this ball is going to fall off the table and land some distance, delta x, horizontally away from the edge of the table. And so a lot of times these problems will give you how fast the ball is rolling and how high the table is, and ask you to solve for the time and to solve for the range. So you'll start by listing your chart, that the acceleration is 0 and negative 10. You'll write down that your starting velocity in both directions is known. And then knowing that the height is 2 meters, you have to be a little careful with this. This is our delta y information. But for our delta y information, we're going to say that it did go 2 meters, but it went 2 meters downward. It fell down 2 meters. And that's why we're putting that negative sign on the delta y. Now what you'll see is there are 3 given variables in that y direction. And so in order to solve for the time, we're going to use the y information, and we can use the bulldozer, but I'm going to write the bulldozer a little different than how we're used to seeing it. I'm going to write the bulldozer with all y's next to it. You can't mix and match your y and your x information. That's the biggest deal about projectile motion, is that if you're using y information, only the y information goes there. So negative 2 equals 1/2 of negative 10 times t squared plus our starting velocity in the y times our time. Now, because it's not moving vertically, that all cancels out to 0. And now I'm going to do that -2 divided by -5 is equal to t squared. And so t is equal to the square root of 2/5. And if I had a calculator right now, I would give you what that decimal was. When I solve for that time, that's actually another variable I can put in my chart. That the time that it took to hit the ground is the square root of 2/5 seconds. And that time that it takes to hit the ground is the only piece of information that's the same in both the x and the y. So the time it takes horizontally and the time it takes vertically are always the same number. And so you'll use the square root of 2/5 as the time both ways. And so that's why we solve for the time first, is that's the link between our two worlds, the x and the y. And so knowing the time it takes to hit the ground, it's actually the same thing as the time it takes to move away from the edge of the table. Now I have 3 factors that I know in the x direction. So to solve for my range, I can use my equation in the x direction, that it's 1/2 of my x acceleration times my time squared times the starting velocity in the x. So to find my range, I'm going to plug in that the acceleration in the x direction is 0. And so even though I know the time squared, that whole piece is going to turn out to 0. Really, the way that it turns out is that because it's at a constant velocity in that x direction, that this delta x equation is always going to simplify to delta x is equal to the x velocity times the time, because this is our constant velocity equation. And so in the x direction, we're maintaining that constant velocity. And to know how far we went, we just have to multiply how fast we were going times the time it took to hit the ground. And that would be the answer for how far you went from the edge of the table. So that is how you mathematically would approach these problems, is your link is that the time in the x direction is the same as the time in the y direction. You always know your x acceleration and your y acceleration. Your hidden variable is going to be this y velocity. When you're launched horizontally, it's up to you to know that when you're launched horizontally, the key to solving these problems is to recognize that your starting y velocity is 0. We could even draw a nice little motion map to go along with this. We could pick a few places right at the beginning, intermediate, and towards the end. And we could say that horizontally, that velocity is going to stay 3 meters per second the whole time. That horizontally, our velocity is not changing. Our Vx is always equal to 3. But our Vy is going to start off as 0 right when we leave the edge of the table. We're not moving up and down. And then our Vy is going to become negative. And then our Vy will become even more negative. So be careful. We don't talk about the velocity on the ground ever. We're always talking about while it's in the air. And to say that the starting velocity in the y direction is 0 just means that it's not moving up or down as it leaves the edge of the table.